Imagine a world unlike our own. Think of a planet that does not spin like a top as it journeys through space. Our Earth rotates once every 24 hours, giving us the familiar rhythm of day and night. This constant turning shapes our weather, our oceans, and honestly, our lives. Now picture a world that is locked in a constant stare with its star. One side of this planet is forever bathed in sunlight. The other side is trapped in an endless frozen night. This is a tidally locked world, a place of incredible extremes. It is a world where sunrise and sunset are not events in time, but fixed locations on a map. This cosmic dance is called tidal locking. It happens when the gravity of a star pulls on a nearby planet so strongly that it slows the planet's rotation over billions of years. Eventually, the planet's spin matches its orbit. One rotation takes the same amount of time as one full trip around the star. The moon is tidally locked to Earth. That is why we always see the same face, the same familiar craters and seas. For a planet like Earth, orbiting a sun-like star, tidal locking would only occur if it were much closer to the sun than it is now. This is where red dwarf stars come in. These stars are the most common type in our Milky Way galaxy, making up around 75% of all stars. Because they are so cool, a planet would have to orbit very closely to receive enough warmth for liquid water to exist on its surface. Using powerful telescopes both on the ground and in space, we have found thousands of planets orbiting distant stars. We can find them by watching for the tiny dip in a star's light as a planet passes in front of it, a method called the transit method. One of the most famous examples is the TRAPPIST-1 system located about 40 light-years away. This system has not one but 7 rocky, Earth-sized planets orbiting a tiny, cool red dwarf star. Our galaxy, the Milky Way, contains perhaps 200 to 400 billion stars. As we have seen, about 3/4 of these are red dwarfs. If even a small fraction of these red dwarfs have rocky planets in their habitable zones, then the number of potentially habitable, tidally locked worlds could be in the tens of billions in our galaxy alone. Red dwarf stars are incredibly stable and long-lived. While our sun will exhaust its fuel in another 5 billion years or so, a red dwarf can keep shining for trillions of years. Let us begin our journey on the star-facing side of a tidally locked world. This is the substellar point, the place where the parent star hangs forever at its zenith, directly overhead. Any water that might have once existed here would have boiled away into the atmosphere billions of years ago, leaving behind a parched and desolate landscape. Rocks would expand under the constant thermal stress, perhaps shattering over millennia into vast fields of sharp-edged gravel. Now, let us travel to the other side of the world, the hemisphere that is forever turned away from the star. This is a land of perpetual, absolute darkness. The atmosphere itself would succumb to the cold. Gases that we think of as permanent parts of the air, like nitrogen, oxygen, and carbon dioxide, would cool down until they condensed into liquid and then froze solid. The night side could be a place where the air literally snows out onto the surface, forming vast glaciers not of water ice but of frozen nitrogen or carbon dioxide. Between the extreme heat of the day side and the profound cold of the night side lies a special place. It is a narrow strip of land that stretches around the planet like a ribbon. This region is in a state of perpetual twilight. It is a world of eternal dawn or eternal dusk, depending on your perspective. This terminator line, as scientists call it, might just be the most important piece of real estate in the galaxy for finding alien life. It is not too hot, and it is not too cold. A world with one side superheated and the other side supercooled creates an enormous temperature difference. This difference is the engine of a colossal weather machine. Climate models suggest that the winds on a tidally locked planet could be ferocious and unceasing. Imagine hurricane-force gales that never ever stop. But these winds are also the planet's circulatory system. They are the key to preventing the worst-case scenarios of a boiled dayside and a completely frozen-out nightside. Life in the twilight zone would evolve under a very different kind of sun. To absorb as much energy as possible from their crimson sun, plants might evolve pigments that are black or a very dark purple. The constant direction of the light would also shape the very structure of these plants. Plants would therefore grow permanently angled towards it, like a field of solar panels, all facing the same direction. This could lead to strange, asymmetrical forests, with every tree and shrub leaning in the same direction, reaching for the life-giving, unmoving star. The environment of the Terminator line would be dominated by one relentless force, the wind. Imagine plants that grow low to the ground, like tough, wiry mats of vegetation clinging to the surface. They would have incredibly strong and deep root systems, anchoring them firmly against the perpetual gales. The root systems of this alien forest could form a vast, hidden network. The gales would carry them for vast distances along the Terminator line, ensuring the species could spread around the entire habitable ring of the planet. What about the animals of this Twilight world? We can imagine six-legged crab-like animals with low, flat profiles, allowing them to scuttle across the ground without being blown away. To communicate in the constant roar of the gales, they might not use sound. Instead, they could rely on sight, using bioluminescent patterns on their bodies to signal to each other in the dim twilight. Perhaps some creatures would not fight the wind but embrace it. Imagine a life form that is like a living kite or a glider, allowing the perpetual gales to carry it effortlessly around the globe. The rivers and lakes that might exist along the Terminator line would be a haven for life. Here, aquatic creatures could be safe from the worst of the winds. We could imagine something like a fish, but with adaptations for a world where the primary food source, the dark plants, grows only on the banks. Perhaps they would be amphibious. The most likely place to find a stable ecosystem is not on land, but in the water. Aquatic plants with their dark pigments would capture the dim red light. For a tidally locked world to be habitable, it needs more than just a good location. It needs a thick, protective atmosphere. This atmosphere is the planet's thermostat. Gases like carbon dioxide and water vapor are powerful greenhouse gases. On a tidally locked world, a healthy dose of these gases would be essential. Computer models show that with a sufficiently thick carbon dioxide-rich atmosphere, even the night side could stay above the freezing point of its main gases. The most optimistic models suggest that a planet could have a global ocean, but it would look very different from Earth's. On the day side, there might be a vast, open ocean directly under the star. The ocean itself would become a massive heat transport system working alongside the atmosphere. This creates a global ocean conveyor belt. It might even create a stable liquid ocean underneath the ice, much like the subglacial oceans we suspect exist on Jupiter's moon Europa. This hidden dark ocean could be a vast and stable habitat for life. When the James Webb Space Telescope stares at a distant world, it's actually searching for the chemical fingerprints of life in its atmosphere. Finding oxygen and methane together in the atmosphere of an exoplanet would be, honestly, a stunning discovery. It would be a powerful hint that some kind of biological process is at work. We'd also be searching for water vapor, the essential ingredient for life as we know it. Confirming the presence of a thick, water-rich atmosphere would be the first step. Our search for life has, for good reason, focused on finding planets like our own. But the science of exoplanets is telling us we need to broaden our search. The most common potentially habitable planets may not be blue dots, but pale red dots. This is why systems like TRAPPIST-1 are so exciting. They are perfect targets for our most powerful new instrument, the James Webb Space Telescope. The discovery of such a signature on a tidally locked world would be one of the most profound moments in human history. It would prove that life is not a fluke unique to our spinning blue planet. Studying these strange, tidally locked worlds does more than just expand our search for alien life. It gives us a profound new perspective on our own planet. By imagining worlds with eternal day and endless night, we learn to appreciate the delicate balance that makes Earth so special. Our planet's simple rotation is a key reason for its stability. They remind us that the conditions we enjoy are not the default for a habitable planet. They are a specific set of circumstances that we have a responsibility to understand and protect. The galaxy may be teeming with worlds that are habitable in ways we are only just beginning to imagine. They represent a universe far richer and more varied than we ever thought. If these tidally locked worlds can host life, and if they have had trillions of years for that life to evolve, could they be home not just to microbes and strange plants, but to complex, intelligent beings? The possibility that we share the galaxy with beings who evolved under a crimson twilight sun should fill us with a sense of wonder. It reminds us that the universe is not only stranger than we imagine, but stranger than we can imagine. Our journey across the cosmos has taken us to some of the strangest and most fascinating worlds imaginable. We have traveled from the blistering furnace of a planet's dayside to the profound, frozen darkness of its nightside. These worlds really force us to abandon our Earth-centric biases. The familiar rhythm of day and night is just one way to create a habitable world. A tidally locked planet offers another path. Life there would be utterly alien, adapted to constant light, eternal twilight, and ferocious winds. These are not failed Earths. They are a testament to the universe's ingenuity. With tools like the James Webb Space Telescope, we are beginning to peer into the atmospheres of these nearby worlds, searching for the chemical fingerprints of water, of protective atmospheres, and ultimately, of biology itself. The story of tidally locked worlds is no longer just a thought experiment. It is a scientific frontier, and we are the generation that gets to take the first steps across it. The two-faced worlds are waiting, and their story is just beginning to unfold, ready to discover whatever secrets these twilight realms may hold.